Hi, I'm Lauren Friedman. In today's video, I'm going to teach you all of the line analytical geometry. So this is the stuff that you should have learned in grade 10 maybe and grade 11. I teach it with an example. So I'm going to give you the method as we're going through an example. So for example, here is a parallelogram. It says A, B, C, D is a palm. It's drawn on the board. Now, if they don't give you a drawing, always draw it. Your brain does what it sees. It doesn't do what it imagines. So it gives me the coordinates. The only thing that's not given is C. And usually if it's not given and you have to draw, it will go in the order A, B, C, D. It won't go A, B, C, D. Okay? So, first question says find the gradient of AB. So question A, gradient is M equals y2 minus y1 over x2 minus x1. Now what I would do is I write M of AB, just in case I need to come back and use it, I've got it written down. So M of AB, it doesn't matter which you use as y2 or y1, as long as it's from the same point. So 3 minus 1 over 1 minus 4 becomes 4 over minus 3. Okay, all right. So that's my gradient of AB. The second question says find the gradient of DC. Now you look, we don't have 2 points, we can't do this. But what do we know straight away the minute they mention it's a parallelogram? That opposite sides are parallel and opposite sides are equal. Okay, so because it's a parallelogram, we can say M of DC is equal to minus 4 over 3 because opposite sides of a palm are parallel. Okay, easy. Find the length of AB. Now remember, you get these formulas, so there is no reason you make a mistake. You've got the formulas and you've got a calculator, so you can cheat with the brain. Remember what I was saying? Cheat with the brain. So we've got to find the length. So length, distance, equidistant, which means equal distance. We're using distance formula. So length, you're going to say AB squared. That's my, now the formula you get on the formula sheet is usually with the square root. I leave the square root out and I square root it at the end. It doesn't make a difference. So it will be x1 minus x2 squared minus y1 minus y2 squared. So it is AB 1 minus 4 squared, plus 3 minus 1 becomes plus 1 squared, which becomes minus 3 squared, which is 9, and plus 4 squared, which is 16. So this actually works out very nicely. So it's 25. So AB is equal to root 25, which is 5 units. Now remember, when you're working out length or distance, you have to put units or you will lose a mark. All right. Then, is A 90 degrees? Now in analytical geometry, the minute you see perpendicular or 90 degrees, light bulbs must flash in your head, you're going to do negative reciprocal gradients. Now, remember, for negative reciprocal gradients, M1 times M2 equals minus 1. That is your proved reason for negative reciprocal gradients. So, is it 90 degrees? We've already worked out the gradient of AB. We've already worked it out, and that's why I said write it down, so we don't go rewrite it. It's minus 4 over 3. Now, work out the gradient of AD. Okay, we're going to work out that gradient, which will be also, you should rewrite the formula. I'm not going to for space-wise. It's 3 minus 2, y2 minus y1 over x2 minus 2 over x1, and that ends up being 1 over 3. Are those negative reciprocal? No. Negative reciprocal means that if that is minus 4 over 3, the other one will be positive 3 over 4, and it's not. So you're going to say M1 times M2, which means if you times them together, they're not equal to minus 1, therefore not 90 degrees. If they were times together and they equal minus 1, so if they're negative reciprocal or inverse with the opposite sign, they will be 90 degrees. Okay. Find the midpoint, question E, find the midpoint of DB. So make sure you're using the correct letters. And it should be, if it's drawn accurately, it should be more or less M. But remember, my drawing on the board is not 100% accurate. So midpoint formula is also you're given x1 plus x2 over 2, y1 plus y2 over 2. Now remember, midpoint is a point, it's a coordinate. Please put it in brackets. So minus 2 plus 4 over 2, and 2 minus 1 over 2. We're just plugging in the values, so that is 1 and that's a half. And if we've drawn it accurately, it looks pretty accurate, even though this isn't correct. So it's 1 and a half. And now if I made up with a point there, you've made a mistake. The picture is not wrong and they're not trying to trick you. So I write down everything the same as in geometry. Everything I write down, I work out, I write down. So now we've got the midpoint and let's call it M. Okay, so there's M. Now it asks me, this is my favorite question, it asks me for C. Now C is the fourth corner of the parallelogram. So they could say to you, they could also say find the fourth vertex. Vertex means corner of the palm. Okay, so finding C is the fourth corner of a palm. And the easiest way to do this is reverse midpoint. So now, even if they didn't ask you this question, you would know that diagonals of a parallelogram bisect, which means they cut at the same midpoint. So you would work out the midpoint of that diagonal you know, the 2 points you know. In this case, they've stepped you through it. So we worked out the midpoint is there. The midpoint of that line has to be the same. So we're going to work backwards. So reverse midpoint means we still do the midpoint formula. So we're going to say 1 plus x over 2, that equals my answer. And then we say the y value 3 plus y over 2. So remember, x1, y1 plus y2 over 2, x1 plus x2 over 2, but it equals my answer. So if you don't have a value, you still use the formula, but you put it equal to the answer. So now we do two little mini equations. We cross multiply, so x equals 1, and here 3 plus y equals 1, the 2's disappear, so y equals minus 2, so C will be the point 1 and minus 2, and if it's drawn pretty accurately, that should be right. Okay. Then it says find theta. Now, in our final video of this course, I'm going to do a bonus video of finding a theta up there, okay, but let's in this case say find theta over here. Now they could ask you two things. They could say find the inclination. Now inclination, if they use the word inclination, inclination always means from the right hand side up. So in this case it would be there. But here they're actually stipulating find theta. They didn't say find the inclination. So we always use the gradient of the line that it lies on. So we've actually worked out the gradient of AB. So they're saving us time. And the gradient of AB, we've worked it out, was minus 4 over 3. We then use the formula m equals tan theta. So minus 4 over 3 is the gradient, equals tan theta. Now when you do this, you say, remember from our trick videos, when you're finding theta, you say shift. So shift tan, and you say minus 4 over 3, and we get a negative angle. We get theta's equal to minus 53,13. Now we can't use a negative angle. What you have to understand is that's a negative gradient. So in this case, minus 53,13 is there, but we just take away the negative. That is 53,13. If they ask me for the inclination of AB, you would then say 180 minus that to get this. But they never use the word inclination, they just ask me for theta. So theta, just call that theta 1. The theta that they've actually asked us for is 53,13, and remember to put degrees. Okay, so now, all right, the last question says, find T if A, B, and F are collinear. Now, collinear means co, together, linear, on a straight line, together on a straight line, which means they've got the same gradient the whole way along that line. That gradient is the same as that gradient, is the same as that gradient. So once again, I'm using the same line. The gradient of AB we've already worked out. So if we do H over here, just to fit it in, the gradient of AB, just going to dry my board in case it's a bit wet. Okay, the gradient of AB, we've already worked out is minus 4 over 3. We've proved it. Okay, so the gradient of BF must also equal minus 4 over 3 because they're collinear. They've told me they're collinear. So now we do reverse gradient. We've got the gradient, but we don't have that. So we say Y2, we say T minus minus, so plus 1, over 6 minus 4 equals minus 4 over 3. We cross multiply again, so 3t plus 1 equals minus 4 times 2, that's 6 minus 4 is 2. So 3t plus 3 equals minus 8. 3t is equal to minus 11, so t in this case would be minus 11 over 3. Now I want you to stop this video, pause it, etc. Look at the questions, try and do them yourselves. This covers basically all of your line analytical geometry. Okay, in the next video we're going to do circle analytical geometry, and I'm going to bring in straight line there as well, which I could have asked for here, finding the equation of a straight line, but I'm going to bring that into the circle analytical because it's easier to ask it with those questions. And in your analytical section you will get a question like this, okay, with straight line and all of your straight line methods, and you'll get a circle analytical question, and that generally makes up a big chunk of your paper, and it's easy marks if you learn the methods. What they could have asked here, there's another way, and it usually comes up with a triangle. It's easier if they ever give you equations of lines. So they tell you that equation and that equation, and they ask you for a point like that. You have to remember that that is where the two lines meet and it's point of intersection. And remember how we find point of intersection? We did that in our algebra and our function lessons. We make the two lines equal to each other. We solve for x, and we put x back in, and we solve for y. All right. So we will come across that in other videos. So this basically covers all of the line analytical. Please watch carefully. Please practice yourself. Redraw the picture, and then put it to practice in your own sums.